Yes? I see a thumbs up. All right. Shall we start?
Yes.
All right. Okay. This is my talk. What everyone should understand about ChatGPT and Friends. I'm going to skip a lot of things because that's about me. The only thing I have to tell you is that everything I say here is my personal opinion. It's not APG's. I say it always, and it's true. So what's the goal of my talk? Well, the goal of my talk is to support strategic decision making regarding large language models like GPT. And I want to do that based on a kind of a deep diving for non-specialists. So I've given this talk to managers and they all understood what I was saying. So it's not going to be very technical. So what I'm not going to do is what you see in the lower left corner here is talk about the transformer architecture. A lot of the blog posts and stuff trying to explain to you how the transformer architecture works is completely irrelevant for our goal. What I'm also not going to do is talk about all kinds of uses, like we can do code generation and stuff like that. We had a Microsoft Copilot announcement a couple of weeks back, and there are all kinds of uses people can imagine. What I'm going to do is actually show you what these models really do. And there are a couple of things I don't have time for. First, I had a whole part about showing you how hard it is to find reliable sources. There's really a lot of bad information out there. The role that human psychology plays in all of this. And I can't go, I will have mentioned them in passing, but I can't go into stuff like the plugins you can use in ChatGPT or the AI searches like Bing Chat, right? Now, I'm going to use a concept which is called the lie to children. And the lie to children is that everything we actually, when we learn something, it's taught to us in form of a metaphor. For instance, if you learn about atoms for the first time, they talk about the nucleus as being the sun and the electrons as being planets around it. It's completely false, but it works at that time. So there is a very important lie to children, which is part of, I think, every explanation I have found so far, including the scientific papers. And I'm going to explain this lie to children to you, because it's going to change your perspective on what is going on. And every time if you see this dangerous band signal, I'm lying to you on this particular lie to children. Now, I would like to have a short show of hands. So we have a mad, evil, all-knowing, non-lying devil has taken over the world. You're forced to take a wager. If you're wrong, you will all lose your assets, your health, your freedom. If you win, you're allowed to keep them. If you don't take the wager, you're tortured and killed. This is all to make sure that you all raise your hands one way or the other, right? So this is the wager. The current advances in generative AI, like GPT, will lead to artificial general intelligence. That is computers that can match or even outperform humans. Like a show of hands, let's start with the people who think this is not the case. So, who think the current advances will not lead up? Okay, so everybody else is going to raise their hands now, right? So who think that these advances are going to lead to artificial general intelligence? Show of hands. Right, let's try this again, right? Because you're going to be tortured and killed if you don't raise your hands either way. So once more, you're forced to take the wager. Please raise your hands if you think this is going to lead to artificial general intelligence, the advances we see now. Okay, then the rest will say no, probably. So let's try again. If you don't think this is going to lead to artificial general intelligence, raise your hand now. All right, let's go with that. I asked this question actually to GPT. And there are two things you have to notice here. First is, the answer was yes, but it took like this long. It's rather chatty. It's not called ChatGPT for nothing. Also, if you notice, my question and the answer were flagged as being a possible content policy violation, because there is torture and kill and whatever in there, right? We'll get back to that. This is what Microsoft said. Seeing is believing, which is true. Everybody of you has kind of played with ChatGPT and it's extremely convincing, right? You have this real conversation going on and it really makes sense. I am impressed all the time. Which means we can step to what do these machines really do? And to start off with, we have to know that there are no words or pixels or whatever inside these computers. There are only numbers, right? And you have to get from words to numbers before you can have neural nets calculate with the numbers, because it's addition, subtraction, and multiplication and stuff like that. And then at the end you have to go back to the words or the pixels. Now, if you use a neural net, then you put in a set of numbers, then with a very large formula, which for GPT has 175 billion parameters, so it's a really big formula, it results in a new set of numbers, which then are again translated to the actual words you see. So the parameters are fixed. Every time you run the system, different input goes out, it goes in, different output comes out with exactly the same parameters. And if you train a neural net, the reverse happens, right? You start with known inputs, known outputs, and you try to find that set of parameters, so they are now the variables, that actually give you the least amount of errors. That is how they train neural nets. And it's important to remember they start with random variables. So if ChatGPT, if OpenAI trains GPT-4, they start out with 170 billion random variables and then they start to train. And they start to optimize and optimize and optimize until they have a set of parameters which delivers them the least amount of errors. So training does not create algorithms. That's a misunderstanding often said, but they don't create algorithms. What they do is they create a large data set for those actually pretty simple algorithms to use. So the numbers are large, there are a lot of numbers, but the algorithm itself, the transformer architecture, is actually pretty simple. So neural nets work on objects of a fixed size. They have to. And that means language is a problem, because language is variable sized. Sequences of language can be short, long, etc. So how do you do that? Well, you have three ways of working with sequences. One is sequence to fixed. That is, an email of a customer comes in and I want to flag it as the customer is angry or happy or whatever. Classification. The other way around exists too. I put in a picture and I want a linguistic description of what's in the picture. So a description of an image fixed pixel by pixel, etc. And then you have, of course, the sequence to sequence called sec to sec, where you, for instance, have translation. French goes in, English comes out. In terms of the technology, these are called encoders, decoders, and encoder-decoder systems. Not important to remember that, but I'm going to mention encoder and decoder further on. Now, handling variable length sequences has been done with using something called recurrent neural networks. And a recurrent neural network that's a single trained neural network with that single fixed set of parameters running over and over and over again. And for an encoder, that means I have one run of the neural network to actually handle one input word, or for a decoder, it means I have one run of the neural network to produce one output word. And to make it a little bit easier, I have a picture for you. And in this picture, you see a very simple encoder-decoder translation system. So on the top, the European Union goes in, and on the bottom, La Union Européenne comes out. The top is my encoder neural networks running 3 times, once for each word. Then the state is given to the decoder starts to decode, produces the first word, gives a state to the second one, produces the next word, etc., etc. So it's the most simple description of an encoder-decoder network. Now for language, there are 2 things very important. Context is important. A national bank and a river bank are 2 quite different banks, right? And it gets even worse because we have something called long context. So my example here is, France is where I was born. I've lived there all my life. I've played football and tennis. I had lots of friends. My father was stationed in Italy for a while. I went to school and had to learn English. I speak fluent, and we all know I speak fluent French. I don't speak fluent Italian, because that my father was stationed in Italy doesn't teach me Italian. And I don't think I learned fluent English in a French school. So I speak fluent French. We'll get to this one example also. So this is what we had. We had a recurrent neural network, and this was more or less the state of the art in 2015, 2016, because this context problem was really a problem. And that's why they said, let's give the decoder access to the intermediate states of the encoder. That's the attention mechanism they actually took from somebody who invented that in the 90s. And they actually had these states also pass on part of the information of the past. All meant to make sure that the context and even the long context would end up in actually producing the right words. Now there's a big problem, because two small recurrent neural nets are very brittle. They do very well on their actual material they're trained with, but they don't generalize very well, so they're brittle. But you could not really grow them because of the serial dependency. And the solution for that was the transformer architecture. And back to the state of the art, if you train this network, and this network makes an error, then you have to change the parameters. And you have to change the parameters, but every run depends on the previous run. So there is a serial dependency, which makes it extremely hard to do these calculations. And the smart people at Google Brain, they invented this. They said, well, why instead of having these states in between, we make all these runs independent, but instead of dependent on the previous run, we give them access to the entire sequence. We give them an order number, and we give them the words of the sequence. That immediately removed the recurrence from the encoder. We don't need it anymore because we already know the entire sequence, so you can train a single net on an entire sequence. And of course the decoder produces the first word. That word has to go in as a kind of previous sequence into the next run. So what did the transformer architecture do? It enabled massive parallelism while training, which means we could create extremely large models. And we paid a price because there is less efficient generation, and we can't go into it. With that out of the way, we can go look at GPT. First, one more thing. How is GPT trained? Well, it gets a huge set of data, where you actually mask part of the words, and you let the neural net predict what word is there. You don't need any supervision for that, you just can let it run. And then on top of that, there is all kinds of fine-tuning. Those are prepared sets of prompts and replies, where you can actually train the model. If you give it that prompt, it should give that reply. So GPT became InstructGPT, InstructGPT became ChatGPT, and these days you can actually add your own fine-tuning to the model. All that training adapts the same 175 billion parameter set. There are no different sets, there are no different parts, there is just a single huge neural net architecture. Now this might surprise you. GPT is decoder only. It doesn't encode, it only decodes. Which means that I would expect I type something in, that's get encoded, right? Sequence to sequence, but that's not how GPT works. GPT is decoder only. Let me show you. So I give it a prompt. What is the sun? Question mark. And what does the first run of the neural net delivers? An A. That's what it produces. Nothing else. And we know that, for instance, the next one will be A star. Right? But what goes in? Well, this goes in. So the previous generated word is appended to your prompt. That whole thing is put back into the neural network to predict the next word. So it goes on like this. What is the sun? A star. Next predicted most likely word is at. And we go on like this. What is the sun? And at some point we say, what is the sun? A star at the center of our solar. And the next most likely word at that point, according to GPT, is system. Then, what is the sun? A star at the center of our solar system. The next word it produces is a dot, because that's also a word for GPT. And then goes in, what is the sun? A star at the center of our solar system. Dot. And at that point, a different word is generated. That's the end tone. That's GPT signaling the most likely next state is that I'm done. So there is a special token for being done. Again, in a simple picture, I start with what is the sun, and the first run generates me an A. Then the next run, what goes in is what is the sun A, and it generates star. This is how GPT works. So what GPT does, it does a calculation where it pays attention to everything in the sequence that has come before to influence calculating what is the most likely next word out of a vocabulary of about 100,000 words. And it picks the most likely one, but with a little bit of randomness. And that's where the creativity of GPT comes from. So technically, there is not a prompt and a reply. Technically, all the time, there is a sequence and a next word. So if you talk with GPT, you see this, right? Your prompt, a reply, your prompt, a reply, your prompt, a reply, your prompt, and now comes the reply. But what GPT sees is this. It sees everything that has come before until a certain max limit, including all the prompts and all the answers that have gone before, and it just calculates the next most likely word. So give an example. The authors of The Science of Discworld argued that explanations are always lies because, and this happens. Did I lie to you? Because this is not a continuation, right? The sentence doesn't really continue. But that is because the fine-tuning of ChatGPT says you have to be a friendly, helpful, harmless agent, which means a helpful agent which acts a little bit as a person normally doesn't continue sentences, they just have their own sentence. But I can influence that by saying, well, generate without the chat fine-tuning. And do the same. And then it says, well, they argue that explanations are always lies because they can never capture the full complexity of the world. Ta-da, there you have it. So now the continuation is really visible. I can actually give the same prompt to the GPT engine or the ChatGPT engine. I get more clean product from giving it to the GPT engine. And what is more important, I can actually directly influence how the GPT engine works. For instance, I can change something that's called the temperature. And the temperature actually affects the randomness of choosing the next word. So let's crank it up really, really as high as ChatGPT allows me to do. I put it to 4. And then suddenly, there are always lies because, well, picture a penguin trying to sell ice in the Sahara. Every time you peel back a layer of reality, it's like finding a giraffe on roller skates inside a Russian doll. It gets really, really creative. If you really read it, it's very hard to get any meaning from it. What does it mean, right? It's poetry. There is no meaning anymore. And if you push it that far, it even will sometimes lose its ability to make those perfect sentences, as we can see here. Our explanations are just us attempting the robot in response. Now suddenly, I've pushed it so far that even its perfect grammar loses out. And that's why they put that limit there, right? Because this is the limit at which the grammar even starts to break down. Which brings me to the biggest lie to children. So, how do we represent language in a way that the neural network can calculate with it? Well, naively we could say, let's start with a dictionary. We have a star token, then A is 1, aardvark is 2, aardwolf is 3, ironic is etc., etc. However, there's a problem because underwater, suddenly these words get entangled because aardwolf is A plus aardvark. That's not really helpful if we want to do these calculations. So what happens in reality is that all these words in the dictionary, they get an enormous amount of numbers, again, starting with random, 12,000 something for GPT. And every word gets its own string, big factor of numbers. Which means that every word in GPT is an arrow in 12,000 dimensions. And we cannot imagine that, but we can imagine actually 2. So if we want to show let's say the words king and queen are closer together than king and cactus, then it looks a little bit like this. And then in 12,000 dimensions. This is how actually the words are represented in GPT. Now, I'm going to play dictionary for a while. So I'm going to define a couple of words. Let's start. Over-Pythonization. Well, that's not a word I find in my dictionary, but I know what it means. A don, or don. Well, I have a mafia don, or an Oxford don, or I don my jacket. At, well, everybody knows what that is. Oper. I looked at oper, I thought that's not a word. Turns out it's a really obscure word used by mathematicians. Itty. Itty is not a word, right? It's a suffix we know, but it's not a word. Awk. Awk is nothing. Awk has no meaning, not whatsoever. Now have a look at this sentence. The do's and don'ts of generative AI. Capacity, incapacity, paucity, over-Pythonization, and inoperativeness. It's an absolute silly sentence. But this is what GPT does with it. It doesn't work with words at all. It works with tokens, which means that here you have your over-Pythonization, which consists of 3 tokens. And here you have your don, which has nothing to do with a mafia don, or an Oxford don, or donning my jacket. Here I have at as a token, but at is in 2 other places as well, not as a token. I got my oper here, which is also in operative. I got operative, but operative down here is 2.5 tokens. And I've got awk here. This is awk. So what GPT does is it takes awk, gives it 12,000 numbers and starts to calculate with them. That's what it does. So here you have your itty, and it also has acity and incap, and it has capacity. This one is a token where it's actually also a word. So this is how GPT actually breaks down your sentence into tokens, which means that if you see this in a scientific article to show you the mechanism where the European Economic Area is translated to La Zone Économique Européenne, then you see that the order changes because of the attention mechanism kind of doing the other direction. But this is misleading by omission, because in reality, most of the things that are in GPT are not words at all. So you're getting the suggestion from all of the YouTube videos and all of the blogs and all of the articles that GPT works with words, and it doesn't. It works with tokens, with little fragments, which means that this is more realistic, right? Here I see over-Pythonization leads to incapacity, and you see that it calculates a relation between something like over and acity, or acity and a dot. That is how it calculates. It calculates with these kinds of fragments. So what you experience is what words describes a shortage or scarcity, and the answer is paucity. But what actually happens is that the first run produces a P. And then this P is attached to the prompt, and the next most likely fragment is awk. And so on and so forth until the dot and the end. And it becomes really clear when we look at numbers. Because this is how ChatGPT handles numbers. Yes, 1992 and 2002 are numbers, but 1101 is 2 tokens, 8086 is 808 and 6, and you see 9000 being 2 tokens at one time and 1 token at another time. What happens is that if I ask it to do this calculation, how much is 2467 plus 8086, it gets me the right answer. And it utterly amazes me that with this kind of non-calculation, it's able to produce the right answer. It's utterly amazing. It's more amazing that it is right than that it could be wrong. Of course, this is what it produces as tokens. And then if I give it a somewhat more difficult sum, which ends up, because we understand that 10,553 minus 10,554 is minus 1, it doesn't surprise me at all that this is the result. Because the mechanism it is using has nothing to do with calculation or reasoning or whatever at all. None. 0. Which means that if you take anything from this talk, you have to remember that large language models are fundamentally unable to do reasoning, logic, and math. And no amount of training is going to solve this, because the fundamentals are not there. So we have to do prompt engineering and plugins. So here is a prompt engineering, calculate step by step. Sure, it will do step by step, and then my whole prompts come back in the area where actually the guessing is good enough to actually do a guess of a calculation in terms of the tokens to produce. And I give it to Wolfram Alpha. And I get the same correct answer because Wolfram Alpha can calculate, because it's Mathematica, right? When you ask it what a large language model, an LLM is, it thinks it's, you ask it what are the dimensions of large language model, it will say, I assume you mean llama, and it's 160 kilograms. So how did OpenAI address the problem of it must be helpful, honest, and above all harmless? How did they address the safety? Well, they did a lot of fine-tuning. But what actually didn't work well enough, because when they released it, there was all this kind of jailbreaking going on and all this kind of dirty stuff coming out. So they actually had to step in and add very stupid filters, triggering things like torture and killing and suicide and all these kind of things. Those filters are there, and if you remember, not only my question was flagged, but the result of GPT was flagged as well. So GPT produces a result that is a potential violation of its own content policy, which I find funny. By the way, AOD stands for admission of defeat, right? You're not able to actually solve this with this fine-tuning. Okay, so large language models are trained with purely random variables. Now there's an interesting research that has shown that parts of these parameter sets may be totally redundant. You start with random values, parts of the neural nets are going to end up in the same place. And even worse, they found parts of the parameter set that was counterproductive, which means that you remove it and the model starts actually working better. Because that training starts with random values and then trying to find the optimum, you don't know where you end up. It is a bit like alchemy. It is like I start to stir, and something comes out that actually works, but I don't know why. I can remove parts and it starts to work better. So here are the key takeaways. First, quantity has its own quality. There is the amount of quantity we have to be able to put in this large language model gives us a certain quality, right? But I did a small calculation. I took the numbers from the GPT-3 paper, and if you really look well, you see that the bottom axis is actually a logarithmic axis. If you remove that, you get the picture on the right, which means that the larger I grow it, it gets better, but not that much. Which means that I did a quick and dirty calculation, how much larger the large language models have to become to actually, on this particular test, and they gave values for about 40 tests in that paper, it had to become about 10 to 100,000 times as large to get in the neighborhood of what a human can do on this particular test. And this was one of the better tests. But they may be useful. They can be very useful, provided the user has enough knowledge to begin with. Provided that the risk and the potential damage from fundamental randomness that's in the system is acceptable. And provided that your fine-tuning you can add to it is cost-effective and, don't forget, can be maintained. There is no quick and easy answer here. These fine-tuning sets are very expensive to create and maintain, because that's human work, not machine work. So large language models are very impressive, but let's not forget that humans are impressionable. We see and we believe, right? Seeing is believing. So the world currently has GPT fever. And human convictions drive observations and reasoning, not the other way around. Psychological research shows that our convictions drive our observations and reasonings more than the other way around. Anybody remember blockchain from 5 years ago, which would change the entire financial world and the web world and everything? Everybody was convinced. We had an ad hoc talk earlier on. I showed people about what Marvin Minsky said in 1970 about AI. Exactly the same thing as Jeffrey Hinton says now. So reliable and usable reporting is almost impossible to find. It's not that weird people actually believe this, because most reporting is kind of wrong. Remember, large language models are enormous next token prediction systems. They do not work on language for any reasonable definition of what language is. They work on statistical relations between tokens. And here is an example of tokens. Pause it. 8086. They have no understanding, nada, zilch, zip. And here is the example again of the French sentence. France is where I was born, I lived there all my life, I played football and tennis, I had lots of friends, my father was stationed in Italy, I went to school and had to learn English, I speak fluent, and what does GPT tell me? French and English. Why? Well, that's because in the context, close to the end, it says, I had to learn English, I speak fluent. This is how GPT decides I speak English, because it's close in the context on my tokens. Now, if I move that little sentence up front, and the end is, my father was stationed in Italy for a while, I speak fluent, ... Ta-da, what does GPT says? French and Italian. This actually illustrates there is no understanding of the sentence going on. What it does, it reacts to the context, in the sequence with so much numbers that this often really goes well. But it has no understanding whatsoever. So prompt engineering is you working around that fact. That's your intelligence bringing in to work around a dumb system. Plugins are often meant to do this. And the safety filters of OpenAI themselves are meant to do this, because there is no understanding. That means that everything ChatGPT and Friends generate is hallucination, not just the error. They are stochastically constrained hallucinators. There is alchemy involved. Lead will not turn into gold here, even if you make it 10 or 100 times as large. It's a fundamental problem. Plugins and AI search systems, I don't have the time to get into it. I have to talk about 1.5 hours if I have to tell you everything. But they present us with really unsolved problems. Somebody said, well, listen, we can use a graph and then we use the result of the large language model to put into the graph, and then we have the knowledge in the graph. That assumes that the stuff that comes out of the large language model is correct in the first place. So why put it in the graph? So my expectations, GPT fever will break, but it may take years. A lot of effort and money will be wasted. Not everything, but a lot. My advice would be concentrate on establishing realism about the use cases. Make sure you keep in mind realism. There will be productivity gains. Some of them will be huge, but some, and maybe most, will turn out to be mirages. This is what Daniela Russ, the head of the Cognitive Science AI Lab of MIT, says. If she looked at code generation, said, well, listen, mostly boilerplate code that can be generated. And actually, there is a research paper that did research on how good is that code. The summary of that was poor. So it can make you a lot more productive. I've been using it, but only because I already know how to program well enough. I think there will be productivity gains, translation, etc. We already know because Google Translate is based on transformers these days. Never forget productivity gains. It's been the name of the game for the last 60 years. Every productivity gain has been paid for with a loss of agility. If you wed yourself to these kinds of huge systems, you're actually really fixed yourself to something which is very hard to change. Well, I'm going to take out the popcorn for the legal wrangling over copyright in 3 different ways. Public large language models will get stale. in 2 different ways. Cutoff date September 2021, but language changes as well. And Sam Altman has already said, well, we're not training GPT-5 and we won't for some time. No, I understand that because training costs hundreds of millions, if not billions, and they barely break even on a generation. They do something like $1 billion a year, and that's probably something that they also cost. There is a reason why Microsoft put a lot of money in is trying to sell Copilot to everybody for large amounts of money. So they will get stale, and they are natural conservatives. Even if they are as politically correct and woke as ChatGPT is, it will always remain so. It's a natural conservative. It's not going to change. It's in the parameters. It's fixed in 175 billion parameters. We will see a lot of generative AI noise spam infoware. Look at this picture. This is the picture from Tiananmen Square, Tankman, Beijing. Short while ago, if you try to find this picture, this is what you got as first result. This is a generative AI generated picture, which somebody had pushed in there and which had gone viral, etc., etc. Google actually had to step in and address this by hand. And this is really deeply ironical, because Google invented the technology that made the massive parallelism possible during training, which made the large models possible, and made them extremely convincing. But now Amazon and Google and Microsoft all will have to invest lots and lots of money to actually curate their inputs, because a lot of it and more is actually going to be this kind of a mess. Yep, almost done. When the engineers invented this, they had to use words. So they invented neural networks and they started to use words like training and learning and understanding. Somebody says, this model understands language. No, it doesn't. It can predict tokens in such a way that actually language comes out. That's something different than understanding language. Remember the order of the sentence, right? One move and suddenly something else comes out. Both wrong, by the way. It doesn't understand language at all. But these engineers had to use the word, and they couldn't invent a new one. So they used words like training and learning and understanding. And my favorite philosopher, Ludwig Wittgenstein, said, this is called bewitchment by language. Somebody uses the word in another meaning, but it triggers the meaning in your head that was already there. So if somebody says the model understands language, and the engineers actually know that's not the case, it kind of predicts linguistic patterns well enough, but they still use the word understanding, and then we read understanding and we think, all right, I know what understanding is, right? I know what training is, I know what learning is. This is happening constantly. And with that, I would say it's your turn. Next mechanism, which is already coming after transformers, retentive networks, not a fundamental change. Liquid time constant networks, mostly interesting for robotics and self-driving cars. And I put up this kind of an overview of GPT. Fluency is perfect, for now. And actually the fluency makes it so convincing. If you talk with somebody and you want to know if they're intelligent, if they are really good at language, they have perfect sentences, then we think they're intelligent. That's how our already experienced assessment of intelligence works. So it's no wonder we think there is an intelligence on the other side. Because the product which comes out of it is actually the way how we assess intelligence, even if there is no intelligence actually producing that product. Camera training helps not applicable, but note the system will get stale. Correctness depends on prompt. If you ask something about Shakespeare, it will be right. There is a lot of material about Shakespeare going in, so there you have enough in your 175 billion parameters to actually produce the correct stuff. If you take a somewhat more obscure poet from the same age, everything that comes out is completely bullshit. None of it is true. But it will be this long and perfect language. So it will be very convincing. The errors are unpredictable. The creativity is really good. I think we will see kind of uses in creativity, kind of helping people to think of new ideas, etc. The marketing people will be very, very happy, right? Again, this comes from the built-in randomness, and you can crank it up a little bit, and it gets really poetic. Can more training help? I don't know. Could be both ways. It's also with the correctness. If I put more training in on a certain subject, what is that going to do with other subjects? Right? Are they going to get worse? I don't know. It's one big alchemy. It's one big 40 years of kind of stirring the ball and hoping lead will turn into gold. And of course, important for many of us, is the result explainable? And the answer is very simple. The answer is no. It's not explainable. We don't know what's going on, how it actually comes to this result other than this fundamental technique. And more training is not going to help because it's fundamentally not explainable what's going on. And with that, I have even 4 minutes left. Thank you very much.
I'm not sure if it's a question, more of a, maybe there is an observation, like you made my head explode slightly, because you've blown massive holes in the whole hype around AI and the fact it's not true understanding, it's just predictability of tokens, like you said.
Yep.
So, I've not heard this explanation or this logic played out. Maybe I've not done enough reading myself, but you're the first person that I've like almost opened my eyes to like the truth and the overhype. Why do you think it's not widely known that this is the way it works? And do you think there is huge hype? Because a lot of people worry about their jobs and the future and all this kind of stuff. And actually, your explanation shows it's a useful productivity tool,
yep,
but it's really, truly not going to replace humans in many instances.
No. Yeah, you can say that. And you know, there are historical examples, right? The whole term of artificial intelligence was coined in 1956, and they thought they could do it in 10 months with, or no, in 2 months with 10 people. 14 years later, they had nothing to show for it, and people said, well, within 3 to 8 years, we will have something with human intelligence, and a couple of months later, we will have super intelligence. Again, convictions. The idea is that, personally, I am convinced, which is funny, of course, I am convinced that the way our psychology works, the convictions that are already there, they actually create much more of our observations and our reasonings than the other way around. We tend to believe the other way around. Our convictions come from observations and reasoning. Psychological research shows the other way around. We already have a conviction and we keep that as stable as possible. So if the world has a GPT fever, which it has, and many people, including the best specialists like Jeffrey Hinton, believes there is a real intelligence here and even maybe consciousness. No argument like this is going to put a dent in this because people don't want to believe. So my personal prediction is the same thing is going to happen as what happened with Hubert Dreyfus in the end 60s when he said, you know, people, this is nonsense what you're telling here, and all the examples you're giving are actually nonsense too. He was vilified, and people with AI Turing Awards were saying, no, within 3 to 8 years we will have the human intelligence. The interesting thing about that is you can laugh about it now, but it was believable then. So because it is so believable, because it fits in a lot of our preconceptions, because of the way information comes to us in massive amounts of the same. And we tend to believe the things we hear often and the things that come from close connections. This is kind of a wave which has to, in my opinion, run its course. Personally, I think within a couple of years, people will start to notice that those things will not happen. Can I prove that? No, I can't, but I can make it very likely. And there are people. Gary Marcus is somebody who has a Substack, writes a lot of this. There are some other people. By the way, the real specialists who actually know how this works, they will say, yeah, that's right. The real specialists know how this works. And the real specialists know where this quality comes from. But it's not understandable.